Welcome back, everyone, to Delta Y. This week I'll be talking about, that's right, still just me, Josh. Thanks to the break, we're still, me and Grayson, hundreds of miles apart. But next week we'll be right back together in the same room recording together. And Grayson did mean to have a microphone for this week, but it got stuck in customs from Amazon. So, guess next week you'll be tuned in again for both of us together. Anyway, this week I'll be talking about scientists who engineered a shortcut for the photosynthetic glitch of many plants have that would boost crop production by 40%. China's new rover that has reached the far side of the moon and landed successfully. A Rolls-Royce plane under development that is 100% electric and shooting for a target speed of 300 miles an hour by 2020. A mathematical understanding into interplant communication using a very long equation. And a little hiccup with a Dutch astronaut who accidentally dialed the wrong number while in orbit. Once again, this is Josh, and welcome to Delta Y. Alright everyone, so my first article for this week is on scientists from the University of Illinois who have found a shortcut for a photosynthetic glitch, which would boost crops by 40%. So essentially, when plants are, creating energy using photosynthesis, but they also have to do a photorespiration, which is anti-photosynthesis, because they have to obviously breathe. Now, what this means is that photorespiration is a very complicated process and it takes energy, and it goes through three components in a plant cell. However, these scientists have engineered a way to alternate where this goes. So instead of going through three compartments, it goes directly through. And what this does is it saves enough resources to boost the plant by 40%. So when they're saying obviously a 40% yield increase, it's not, they're not boosting how many plants, they're boosting what a plant can do. And by, decreasing the distance you have to go for photorespiration within these plants, they're allowing them to use more energy for their photosynthesis. And this is really cool because it's an interesting way to see that they're, creating essentially a much easier way for things to work within a living organism. Which, makes me think about humans. What could humans do to make themselves work better for less energy? What kind of pathways could be reduced in our bodies? Now, obviously, that's a long, long time away. This still has, possibly a decade until it comes into full effect. But, this is really cool because it could, drastically increase the amount of people that could be fed. This was obviously tested on tobacco because it's an easy plant to modify and grows very easily. But they're translating this into soybeans, cowpea, rice, potato, tomato, and eggplants. So these are all food plants, right? So they're saying that if they get this to work within the next decade, they could feed an extra 200 million people that are per the calories lost in photorespiration in just the Midwest U.S. So, that's all the corn states in the U.S. in the center. But, think about that. An extra 200 million people just by changing a pathway in a plant. That's incredible to me that they're seeing this where, if you can reduce what a plant has to do, you'll increase what the plant can do. And this is really interesting because it's just a new feat of engineering that increases efficiency. And, this is a logical step in human development and just in nature development to find the most efficient way to do things. Now, obviously, this is, interesting because usually we see nature testing this out and evolving through this. But by doing this, we're accelerating evolution within plants and seeing a evolution of the plant that we wanted, which is really cool to see. We're modifying things that isn't harming anything, isn't creating any problems. It's just creating solutions to problems that we already had. So this is really cool and something definitely to follow. And it was from the University of Illinois, once again, with the Department of Agriculture. But, just think about that. An extra 200 million people that you could feed just by changing the gene or a pathway, by changing some small parts of the way a plant grows. I just think that's really cool. Moving on to my next article, which is on something most of you have probably heard of, which is China's spacecraft that reached the far side of the moon. So they landed this in the deepest and theoretically oldest crater within the moon. It's just by the South Pole. It's called the von Karman crater. I'm sure I butchered that, and I'm not going to try to pronounce the Chinese, probe's name, because I will butcher it. But it's named after a moon goddess in Chinese mythology. Now, this is the second rover they've landed. I mean, they did this back in 2013, but that was a easier one on the the close side of the moon. But now that they're on the dark side of the moon, this is something that no nation has really done. I mean, we have pictures, tons of pictures of it, but no one really landed a probe there. And so this is a big step forward for China, which is really cool to see. And they're saying that, this is going to advance them into the class of deep space exploration. They're planning to operate a third space station by 2022, and their goal is to put astronauts on a lunar base later in the 2020s. And they want to return probes to send probes to Mars that could return samples. This is all stuff that is good to see in the scientific world. It's good to see competition again, because we haven't had this kind of space competition in decades. And it's good to see that this could, step up other nations to do more and more research and more exploration of the solar system, and obviously further past that. It's really interesting to see because China actually launched a satellite to act as a relay, because you can't go directly from the far side of the moon to communicate. So they're using this satellite to bounce it off that back to Earth. But, it's not too hard because, this is something that we've done before, right? We've been to the far side of the moon. We had astronauts go around it. But this is something new, like we're exploring it more in depth than with just rover or with orbital cameras. Now, it's a 300-pound rover that'll roam the crater. And this is really interesting. It's just going to roam the crater, but it's a big crater. It's 110 miles wide. And the reason they shot for there is because it's, one of the oldest craters on the moon, which would mean that it would have the oldest parts of the moon. So possibly they could find out more about our moon, because there's a lot of theories on how the moon formed. And, there are a lot of them conflict. So the idea is to find out the moon's origins and how it is evolved over the years. They're suspecting that the surrounding basin may be rich in minerals. And, thinking about space mining, this could be the next step in space development, where China could be ahead of everyone else because they know where and when and what is on the moon. So that's really cool to see. And it's interesting to see, if we get astronauts back on the moon and living on the moon in a decade. I mean, think about it. It's 2019 now. Happy New Year, everyone. But, next year's 2020. They're saying third station by 2022. They're saying astronauts living on the moon by no later than 2030. That's incredible, because we're really far forward compared to where we thought we were. I mean, we're in what everyone called the future back in the 70s and 80s. So we're seeing things that are futuristic now. And this is really cool to see. This is obviously something to follow. It's good to see that they succeeded in this, that they had a successful launch, everything went well. Obviously, since their last probe did have a mishap, which stopped it working, it's hopefully we'll see this one work much better, because this is a fundamental and very vital thing for, scientific exploration of space. That is obviously it's a worldwide thing. Everyone should be connected in this. Obviously, competition is good to get things to space, but information is something we should all be sharing. Anyway, moving on to the next article, which is, from Rolls-Royce. Now, obviously, a lot of people think of Rolls-Royce as the car maker, but they make a lot of the jet engines for, I believe, Airbus uses a lot of their engines. Obviously, a lot of smaller planes use their engines. But right now, they're working on something they're calling Accel, ACCEL, all caps, which is interesting. It's going to be kind of harnessing the ideas from Formula E, which is the electronic variant of Formula One, which is currently its 5th season. They debuted their second car. I'm kind of a nerd for all things racing, so I know all about that. But this is really interesting because it's going to be a battery-powered single-engine plane, single propeller plane, single-seater, which has a top speed of 300 miles an hour and a range of 200 miles. This is incredible because obviously, planes aren't electric for a reason. The loss of, there's a curve there that explains why. And it's interesting to see that curve because per weight, you have to have more and more power. But this thing would deliver a maximum output of 750 volts with a 90% efficiency. So that's really cool. It's going to have more than 500 horsepower. And it's going to be, obviously tested next year. I say 2020, but I'm thinking about it in my head now. I'm like, that's next year. That's awesome. The current world record is 210 miles an hour set by Simmons in 2017. And as we see this kind of competition, again, competition comes up a lot for me. As we see this competition advance, we're going to see more and faster planes with longer ranges. They're going to be able to do more. And by harnessing electricity in this way, we're going to create a cleaner environment, obviously. We're going to have less chemicals, less jet fuel used, everything like that. And this plane obviously has a lot of testing to go through, a lot of trials to go through. The idea has to be solid. It's going to weigh a lot. And that's the biggest problem, is why we don't see more electric planes, is weight. Batteries weigh a lot. We need to find an alternative still for our power issue. And that's why, I believe, some universities, there was a university I talked about last week, I believe, that did an ion plane. I watched a video about it, I believe, that was working on an ion powered plane. Kind of like, most spacecraft are ion powered. They're solar planes and everything like that. But we haven't had anything battery powered. So this will be something interesting to follow. And it, flies out next year. So, out of the UK, that's definitely good to see. And we'll have to see, how it performs and everything about it and how it works. Anyway, moving on to our next article, which is a mathematical approach for understanding intraplant communication. And I'll be sure to link this article so you guys can take a look. This is a very, very, very complex differential equation. That's what it looks like that to me. Now, this is from Italy, I can tell. I'm looking at the name of the researchers. It's the researchers at the Gran Sasso Science Institute and the Istituto Italiano di Tecnologico. I just butchered that so hard, and I'm sorry for anyone who does speak Italian or is Italian that listens to this podcast. Anyway, they published a paper that showed that plants work on a certain complex behavior pathline. So by, working out how plants process and manage their network, they could create a model that shows how this works. So obviously, no models really before had worked properly to show the complexity of a plant's internal communication network. But what this equation was, the study and everything about this was meant to do was to show that plants were, very complex, but also you could find how a plant grows and how it processes information, like how it processes itself and how it works through this equation. So, this equation describes the dynamics of an intraplant communication and analyzes the possible cues that activate, adapt growth responses in a single plant. That was a direct quote from this article. But this is really cool because this article covers a lot more than previous models. So their model covers elements including photosynthesis, start degradation, multiple nutrients uptake and management, biomass allocation, and maintenance. So by putting all these together, you're creating a model that shows the exact behavior on how a plant could work with stimulations. And this is really cool because we're looking at, by creating this model and seeing how a plant works, could we use this in robots? They're tending to think so. This could be useful in mathematics, robotics, and biology, and all sorts of different things for creating a simple but also complex robot that could do a lot of tasks, but do them consistently and efficiently. But yeah, this is obviously really cool to see because they don't do what most organisms do. They're a very passive organism, but not as passive as we once thought. Obviously they're very complex. And this is like a 10-line equation with variables I don't even recognize. Well, I recognize them, but I have no idea how they're using them. And anyway, for our last article, we're going to talk about a Dutch astronaut that accidentally dialed 911. So, in case you didn't know, astronauts on the space station can actually dial Earth. So, it's not as easy. They're using satellite phones, obviously, because most communication on Earth is actually through undersea cabling, which is much cheaper and easier to use. But so you're supposed to dial 011 for an national line in space. And they have to dial 9 for an outside line, followed by 011. But it's a little trickier to do, obviously, when you're upside down, backwards in space. So he accidentally dialed a 911 instead of a 9011. So he got an email the next day that said, "Did you call 911?" Because when he did this, it set off a security alert at the Houston Center. And they had to go and look, why did they call 911? And this astronaut, whose name I'm about to pronounce, or attempt, so he's Dutch, is Andre Kuipers. and I'm sorry, sir, if that is not how you pronounce your name, but this is a hilarious thing because he got an email that was like, "Did you call 911?" And he's been joking about, he's a bit disappointed that their response time wasn't faster, that they didn't get up there to him. But this man has completed 203 total days of space travel, which is 2 missions that he's done. But he said that astronauts can actually reach terrestrial phones using satellite phones about 70% of the time. But the delay is obviously very difficult because you have a very long delay. So you got to talk, it's going to be a talk, a pause, a talk, a pause, but very exaggerated. It's very interesting. This man he's also 60 years old. So he was 10 when Neil Armstrong set foot on the moon. And he doesn't remember that event. But this is really funny to read. It's interesting to think that we don't even think about this, but people in space could call us, and we wouldn't know they're in space really. We'd know that they have lag in their phone system. But it's like, that's really cool that, we have people that are doing that. So anyway, that just about wraps up everything I wanted to talk about this week. Once again, Grayson's got a notification that his microphone was stuck in customs from Amazon. So, next week we'll be back together, so we'll be able to record. But once we get that microphone, we're hoping that, we could do guest interviews with people we know in the field, along with just, a little bit better quality for both of us. Obviously, I sound a little bit better with just one microphone than both of us using it in a certain mode. But anyway, I want to thank you guys for listening again. Thank you for tuning in this week. But a little bit shorter episode this week, obviously, they have been for me, because I don't talk quite as much and I can't have a conversation with myself. But anyway, I want to thank you guys for your continued support. I'll be linking all our social links below in the description of this podcast. I'm still only uploading these on YouTube because we don't have any more SoundCloud time, and we're trying to figure something out. But down below will be our Twitter, our SoundCloud, if you want to listen to some of the episodes that are still up there. Our Facebook, which I should update, but I never do. I'm sorry. The Twitter, where I actually do tweet stuff. And our Patreon, if you want to continue or consider, supporting us in that way, where we could get, maybe better sound installation, better recording software, stuff like that to up the quality of this podcast. Anyway, thank you for listening. Once again, my name is Josh. Stay creative. Have a great week, and we hope you tune in next time.